now let's get started. Hello, I am Sita Shen. I am a product manager at Setter Data, and I'm also a StarRocks contributor. So today's topic is on uh, Xiaohongshu or RedNote's. So their secret to achieve customer-facing analytics with their huge social media platform with 200 million plus monthly active users, right? So now let's get started. So when you have questions, you can always just share them in the audience chat or the Q&A session, right? So this presentation will be like 25-30 minutes, and we'll definitely have time in the end to address everybody's questions. Okay, so now let's get started. So let's first take a look at the agenda, right? So first is what is Xiaohongshu and RedNote, and then we'll take a look at Xiaohongshu's data architecture, their journey, that going from a scattered kind of like data warehouse Redshift and all kinds of other data warehouse like architecture to like a Hadoop based a data lake to a data warehouse and then to a lake house, kind of their journey, right? And then we'll take a look at the challenges of handling customer facing analytics at Xiaohongshu with ClickHouse, with their first solution, right? And how they solved all of those challenges by migrating to StarRocks. And then we'll talk a little bit about the future of Xiaohongshu's data architecture with Lakehouse architecture and more. Okay, let's get started. So first, what is Xiaohongshu? What are we talking about here, right? So Xiaohongshu, I think it kind of got a little bit of attention in the previous month, right? Because TikTok was getting banned, and a lot of TikTok users or TikTok refugees were flowing into Xiaohongshu or RedNote, right? It was actually a top free app, the top free app on the Apple Store for a significant amount of time, right? It's actually a social platform that was already pretty big, right? It's really big in the Mandarin, the Chinese speaking community, and it was founded in 2013. It has 200 million plus monthly active user. It's a huge company. It makes a lot of money actually itself. It's valued at 18 to 200 to 20 billion USD. It was one of the it is and this was actually a few years ago when they did their last round of funding. So its valuation now is kind of unknown, or right? It's still one of the most valuable private company or unicorns in the world right now, right? And it makes a majority of its revenue, like around 80%, from advertising, right? So selling ads to advertisers that may do ads on their platform, right? It's actually a social media platform that I use a lot, actually a little more than I'd like to admit. So right here, this is Xiaohongshu, right? I'm on here like basically 24/7. So actually, it's a social media platform. You use it to share your life, basically, right? To inspire other people. And actually, I use it for a lot more. Right? If I want to like actually search something instead of Google, actually I go to RedNote to search, right? Actually, I was um, going island hopping, in the Southeast Asia, and we're trying to find places, to do scuba diving, and I use RedNote basically to find everything I do, right? Scuba diving, places to eat, hotels, and everything, right? Definitely has a special place in my heart, RedNote, and luckily we were uh, able to work with RedNote with Xiaohongshu from actually the very beginning of StarRocks. When it was just open source, it was from with us from basically not day one, but from the very beginning, right? Close to the very beginning. And now let's talk about their customer-facing use case, right? So basically, their customer-facing use case is not directly to their users like you with me, right? It is more for their advertisers, right? So they provide those dashboards, customizable, drag and drop kind of dashboards for the advertisers, so they know how well their ad is doing. So in real time, right? So they have the time to actually adjust, their ad to maximize the ROI for their ads for every dollar that is spent on the platform, right? So it needs real-time upserts, right? So basically to extract real-time data insights from like multiple data sources, all kinds of different data sources, right? It's pretty high concurrency, right? To serve every single advertiser and content creator that is on the platform, right? It has many dimensions, right? Something like gender, like age, devices, right? Keywords, just many different dimensions, right? At different level of granularities, right? And a pretty interesting requirement of them it's really dynamic, right? It has new dimensions, changing dimensions, and different combinations of dimensions all the time, right? So you need to query something like that. You need to do a lot of the computations on the fly, or else you will put a lot of pressure on your data pipeline, right? Or that data backfilling, right? And also, new granularities that comes out, that new requirements all the time, right? So similar requirements. And so let's talk a little bit about their data architecture, right? So, it all started around like 2017, right? So back then there weren't that much data and there weren't that complex of a requirement that they had, right? So basically, all of their data projects were like bottom to up. So different kind of data warehouse, different kind of tech stacks, and nothing is really that unified. Data scattered all around the places, right? And if they want to do like pre-computation, sometimes they leave it to the end, to the data warehouse level and do all of them there. And it was acceptable back then, with Redshift, but their data volume grew a lot, during 2017 and 2018, right? That's when Xiaohongshu got really big and started its just rocket, right? And then they moved to a Hive-based, like Hadoop-based Hive storage with Presto on top, right? That does the analytics, right, on top. And then it started okay, right? But advertisers are asking for a lot more. Right? They're asking for more real-time insights, fresher data, right? Fresher insights on their dashboards, right? And Hive is just not the tool to do something like that, right? And then they introduced ClickHouse into the system. Like ClickHouse is a very powerful analytical tool or OLAP database, right? That's able to do near real-time analytics, right? And that worked out pretty well for like a year, right? Until they run into even more issues, right? And then they made changes after that. So our story today will start around like 2020 when they were having those challenges with ClickHouse. We're going to dive into like what are those challenges are and how they solved all of those challenges. Okay, so next slide. So before they were on StarRocks, when they were on ClickHouse, right? So basically, they have the reason why they use ClickHouse is because of real time, right? With ClickHouse, and they also added Flink, to their technology stack, right? So they have data streams and they have Flink tasks that does, the business logic, data cleaning, pre-computation, something like pre-aggregation, denormalization, right? And feed them into a whole array of different databases, to do data serving, right? Like something like MySQL or Redis, when it's very highly concurrent use cases, and for ClickHouse, for those that needs a little more computation at the end, all that kind of computation at the end, right? And that goes and serve those like dashboards and billing and algo strategy and those kind of stuff, right? And the scenarios for ads mostly two, right? So first is ad streaming, right? Those ad exposures, click-through rate, purchasing, those kind of stuff, and how well the ads are doing, right? Like conversion rates, engagement rates, comments and likes, and aggregated result of those, right? And some highlights, of the architecture at that time with ClickHouse, right? They had 20 plus clusters and 1,000 plus data templates, right? And also they have 300 plus business subject areas that this whole thing covers, and each business subject has its own kind of like denormalized table, right? And peak ingestion rate was around 10,000 per second, and that accumulates to around 60 billion daily new records. And this was the number 2020, right, when they were still running on ClickHouse, right? And this architecture did give them a lot of headaches, right? So first, ClickHouse cannot really do join at a scale that Xiaohongshu was operating on, right? ClickHouse is good at join when it's like single instance because this does not do data shuffling, right? So a single instance join for ClickHouse across like something like 2 tables is okay, right? But anything other than that, you're going to run into scalability issues. And so for Xiaohongshu's case, all of the joins needs to be denormalized, right? And that needed to be done with Flink tasks, right? With stateful Flink tasks, and that puts a lot of pressure on their Flink cluster, right? And that lengthened their Flink development and actually test cycle, right? And their Flink was under a lot of pressure, so the performance degrades a lot, for those like complex pre-computations plus the business logics, right? Everything was on Flink. So Flink is a great tool, but if you put too much pressure on it, it kind of it doesn't work. That's the same for every other tool out there, right? Too, and there are other challenges too, right? And ClickHouse is pretty unstable under high concurrency queries, right? And the reason of that is multidimensional, right? I think one of the biggest reason that caused this was because Xiaohongshu had those still has those mutable datas, right? And ClickHouse relies on merge on read, to handle mutable data in real time, right? Basically, when you write into different versions, and in the background it tries to merge, right? But if you write into very small batches, the merge can actually take up like a lot of CPU power, right? A lot of hardware resource, and sometimes often the time, if the data, for instance, like under 2 minutes, for most of the cases, it affects query performance, right? And like extremely unstable performance for mutable data, and very complex data pipelines for 300 plus wide tables, right? And this is from the inability to perform joins, at scale, right? And also, ClickHouse does not really scale automatically, meaning that you have to like manually adjust the data, like redistribute the data, right? With ClickHouse every time you add a new node, and that was a lot of work for them because their ClickHouse cluster was pretty big, right? And also data is duplicated across many different data sources, right? Like I said, because of the concurrency issue that ClickHouse had, they had different kind of different kind of data stores, for different purposes, right? And they had to have them with ClickHouse. So that really creates data silos and different, like the same data copied everywhere else. A data governance nightmare, right? And just to emphasize a little more on denormalization, right? Let's take a closer look, and we're gonna see like how much this actually damaged their business, right? Let's say that we have 2 tables here, right? Let's say a customer table and let's say a fact table, like an order table, right? The customer order things, right? And you have a customer ID here, and you have a customer ID here, right? So the two, joins, right? You have queries that needs to join the 2 tables together, right? But if your query engine does not actually do join, your only option would be to pre-join the 2 table to perform a denormalization between the 2 table, right? And then use that to serve your dashboards, right? But what if one day you want to say change something, right? Do a schema change on one of your table, right? In this case, let's say the customer name table, right? Um, let's say you don't want to like have names here, you have to somehow like mask it, right? To change this to ID, right? Like normally, if you don't do a denormalization, you just change like this, rewrite this column, right? And that'll be it, right? And because this is a left table, a dimensional table does not have that many rows, or you don't have that many customers, right? So you just do that and it's done. But if it's denormalized, right, not only you have to change this table, but you have to backfill all of the rows in your denormalized table, which the number of rows here is the same as your fact table, which is a lot more than what you would have done, right? And actually, denormalization not only it requires you to to do the denormalization, it actually locks your data in a single view format, right? With barely any flexibility, especially when your data size is huge, right? For some of our customer, we do have another customer that builds like metric system, right, for their company, and when they were doing denormalization, it took them like hours, to days to do a schema change, which is just absolutely insane, right? This is not something that anybody should have to endure, right? So denormalization is definitely very harmful, right? So it was time for them to migrate, right? And that's when they found StarRocks, right? StarRocks is a open source Linux Foundation project, right? It's great for low latency, large scale joins and aggregation kind of queries, right? It has a vectorized execution, right? So every single operator of StarRocks is vectorized, right? It also has those specialized features built specifically for customer facing, like workloads, low latency, high concurrency workloads, right? Including query caching, which is an intermediate result cache, right? And it's built to run joins at a scale, right? It has a cost-based optimizer, which is very important when you're joining multiple tables together, right? Just to figure out like the order of join, that's an NPR problem, right? And you do want a really good optimizer if you want to run joins fast, right? It also has an MPP architecture, which means that it can do data shuffling, right? So you can basically shuffle the data while the query is still running, right? So so that makes join scalable, right? You can do shuffle join, and it treats real-time mutable data as a first-class citizen, right? It has a primary key table. It uses a record-level index, to accelerate data upserts and deletes, not like those merge on read approaches, right? So this actually does not impact query performance at all when you're trying to do real-time data upserts, right? Let's say it's like sub 10-second data freshness, right? It also has a very simple architecture with only two kinds of processes, right? So scales automatically too as well, right? And StarRocks is very fast. This is a benchmark between StarRocks versus ClickHouse versus Apache Druid out of box, right? So SSB benchmark was originally a multi-table benchmark test, right? With multiple tables, so fact table and many dimensional tables, right? And this actually, everything with the multi-table here, so with StarRocks, this is the original test. But everything with a flat next to it is a variant of the SSB benchmark test that was actually created by the ClickHouse team, right? As basically, it is a denormalization of all of the original SSB tables into a big flat table, right? And basically, you only do the on-the-fly aggregations, but you don't do the on-the-fly joins, right? But here you can see that StarRocks flat is faster than ClickHouse, and it's way faster than Apache Druid, right? But StarRocks multi-table is even faster than Apache Druid's flat table, and it's even like almost as fast as ClickHouse flat table, right? Performance. So basically, from this you can basically get join for free, but join is probably one of the most expensive thing you can write with a query, right? With a SQL query. So this StarRocks is very fast, as a data warehouse. So after a lot of testing, they migrated their ad platform to StarRocks, right? So basically, they use a few big changes, right? So because StarRocks can actually do those drawings and has better performance, so no denormalization and a lot less pre-aggregation, right? So they actually removed all of the ETLs from Flink, right? So a lot less pressure on their Flink cluster, right? And actually, they also moved all of the business logic to StarRocks as well, right? So Flink basically only do data cleaning, which is put makes the cluster a lot more stable than it was before, right? And also because StarRocks is built to handle concurrency at a very big scale, right? So they didn't need a lot of the other data stores, to do just serving, right? So StarRocks was the only data store left, serving left, right? So basically a unified service, right? So you don't have data siloed everywhere else, everywhere, right? And get a lot of the benefit, right? So first, improved performance, right? Um, from the benchmark, we can also see, right? So improved system stability, right? Basically, a lot less things you're maintaining, right? And a lot less pipeline that you're trying to maintain, right? The denormalization pipeline, the ingestion pipeline, everything, right? And ultimately, it reduces your overall, operational cost, right? And also, there is only one system left, so there's no like the same data copied everywhere else anymore, right? So it's great for data governance. A good data governance means better data quality, right? So they have experienced a lot more improved data accuracy for their downstream applications, right? So some of the results that they had from the migration, right? So their P99 latency with StarRocks was under 200 milliseconds, and their concurrency capacity of their cluster is way over 10,000 QPS, and the number of queries that they actually run a day is in the millions, right? And with a simplified data pipeline, with no denormalization, with less systems, and they're able to do more multi-dimensional queries, right? Because just the raw performance is better, right? So they can drill down more, right? So they can do a lot more computation on the fly with significantly decreased number of pre-aggregation as well, right? And now let's take a look at the future of Xiaohongshu's data architecture. So for this, actually, I want to talk about another use case of theirs, right? It's customer facing is high stake, right? So basically, the use case we just talked about supports their ad platform, right? And that's like majority of their revenue, right? When they test new technology, they often do it on a kind of like an internal use case, right? And this is what I'm going to talk about now. How they're testing with a new concept that's called a data lakehouse, right? So this is their internal facing analytics service, right? So it's called on the top is Red BI, right? So basically, it's a dashboard that their internal analysts can use to create dashboards, to see how their products is doing, right? Basically, all of the things that an internal analyst would see, right? And their legacy architecture was based on ClickHouse as well, right? So they have their original data source from Hive, right? And that into a OSS, right? And then ingest into a ClickHouse cluster, right? And this, they ran into some issues, right? So first is failing indexes, right? Because of ClickHouse performance, they had to build indexes to get the performance that they need, right? But indexes sometimes they expire, and when they expire, the performance just plummets, right? So failing indexes cause a lot of performance fluctuation, right? And also, like we talked about before, right? ClickHouse does not really do join at their scale, right? So they had to do many denormalization pipelines. So with all of the challenges we talked about before, right? And also, ClickHouse is on a proprietary data format, right? ClickHouse's own file and table format. So everything you ingest into ClickHouse, other application is very challenging to read that piece of data, right? But so if you want to introduce another kind of workload or application, you have to like ingest that data into somewhere else, right? And that really creates a data silo, right? And that's a data governance kind of challenge too, right? And also you have to, the very expensive data ingestion pipeline that's into that's into ClickHouse and into many other applications as well, right? And then they found something that's called a lakehouse, right? A lakehouse is basically features of data warehouse on open and standardized storage, right? So you see those lakehouse table formats such as Delta Lake, Apache Iceberg, and Apache Hudi, right? They're basically building those like data warehouse like features on top of Parquet files, basically, right? So why do they do that? The reason is this way they can unify all of the workloads, on a single source of truth of data, right? Because everything is stored in a open and standardized format, right? So basically, user has its ownership of its own data, and it can pick. The user can actually pick which application they want to read, that piece of data, right? Because it's open, right? So that creates, very easy data governance, right? Because there's only one copy of data you need to manage, right? And it simplifies your data architecture, and overall is very cost effective, right? And that's exactly what it did, right? Because they were a StarRocks user from the beginning, right? So they use StarRocks plus Apache Iceberg just for this task, right? StarRocks actually work on Open Data Lake as well, right? As a query engine. So it integrates directly with many different open table formats, such as Iceberg, Delta Lake, and Hudi, right? It has an intelligent caching framework to overcome, the traditionally thought slow performance of data lake or data lake storage devices, right? And has all of the features and performance of a data warehouse. We actually ported all of the features from StarRocks as a data warehouse and that kind of like data warehouse customer facing like experience to the open data lake, right? And this is a test that they did, right? Actually, StarRocks on top of Iceberg versus ClickHouse, with the proprietary storage with the same exact hardware on their top 10 data set on their BI tool, right? By traffic, the top 10 data set. So their actual use case, right? You can see StarRocks is way faster than ClickHouse, even running on Parquet files on Apache Iceberg. Okay, so that's exactly what they did, right? So they replaced ClickHouse with StarRocks, and the storage are all unified on top of Apache Iceberg, right? As a single copy of data, right? So they were able to get 3 times performance improvements over ClickHouse, even it's running directly on the data lake, right? And it saves 50% of their disk cost. And I think most importantly, they get this kind of unified architecture, right? So an architecture that you only manage one copy of data, and you can introduce as many new tools in as possible without the need to actually copy, duplicating your data to those different applications, right? So and all the while, you get the same kind of like data warehouse like performance, on the lake house, on the data lake, on the open formats, right? And this is a really neat experiment that they did, and it transforms, what they are doing, with their internal analytics. And I'm sure not in the near future, they're going to, and even more corporations or companies are going to try to uh, run customer-facing analytics on open formats, right? And that day is coming very soon. Okay, so yeah, this is actually all I have. Customer-facing analytics on Lakehouse, right? You can join the StarRocks Slack to learn more, and you can also try Cellular Data Cloud for free at cloud.cellerdata.com, right? Do we have any questions? Okay, we do have questions. First, from Do, what is the scale of their stars cluster? Actually, at today, I'm not really sure. I have to check with them and see if we can share the number too as well. I'll get back to you on this. Thank you. Next question. How does work with legacy ERP and CRM and SQL Server and Oracle? Can you elaborate the question a little more? Like which part of it works? So if you're talking about StarRocks, StarRocks does have connectors that connects to different data sources, right? And also, if you want something real time, it integrates with Kafka Connect, integrates with Flink, right? If that work with your data source, it can work with StarRocks as well, right? I think this is something we can take offline and we can discuss a little more. Okay, we will reach out to you. Very fast and very big. How do you control data quality and data security? That's a very big question. Like I said, I think like just working with different users and our customers, one of the things that really destroy your data quality is to have just data, the same data scattered around. I think try to minimize that might really help you with your data governance and data quality, right? Hope that answered your question. And what do you mean by, okay, I think what you're talking about here is this, right? This, I think the cache is not the cache that you're thinking about. This is the cache, like say cached a pre-aggregated result. I think this is either the single table materialized view StarRocks or the aggregate table. This is not the cache you're talking about. It's the basically pre-aggregation. Thought of it as a cache, right? Okay. How do they manage real-time metadata updates from Iceberg? How do they manage metadata updates? I think your question is how does StarRocks manage, or how do StarRocks get the real-time metadata updates from Iceberg, right? How does StarRocks get it? So it's actually we do have a metadata cache. So it syncs like it's a timer you can set, how often that the StarRocks FE actually talk to the catalog and get the latest metadata. There's a whole like mechanism there. Yeah, I can send you some more information offline. Can find you in the Slack channel. Next question. Please correct me here. ClickHouse uses index and uses an index to scan and parse. But StarRocks doesn't rely on index, Iceberg. So speed gains are attributed to compute alone. Um, let me try to understand. So, the thing is, I'm trying to think of how to. Um, the second part, yes, the speed gains are basically from StarRocks being just more efficient, right? And StarRocks doesn't rely on indexes on Iceberg. No. Um, Yeah, so basically, we're talking about like ClickHouse like needing a lot more indexes because um its performance is it's not good enough without indexes, right? Actually, Xiaohongshu did a lot more on like StarRocks on Apache Iceberg, the data skipping. They have a whole like a literature on that written. Um, so so it doesn't rely on indexes. So the speed gain, yes, is attributed to compute mostly. Do you know how they run compaction jobs with Iceberg? Sure, I do. Yeah, they do run compaction jobs. Even with compaction, they still run into to metadata performance problems. Just too many of them, right? And actually, we developed a feature called just parallel. So there is a one feature that's in StarRocks that can parallel read, those metadata files, right? And actually, Xiaohongshu was the first user, one of the first user to test that feature. Specifically, how they run compaction jobs, I'm not really that sure. I can connect to you offline and answer you this question. What is the SQL dialect that we can use to query Iceberg tables if we're using StarRocks as a query engine? So StarRocks is MySQL compliant, so you can use the StarRocks dialect, and also StarRocks has a Trino dialect support, right? So you can use the Trino dialect too, if you use StarRocks as a query engine. On the Lakehouse stuff, did they consider Trino? Any idea what the difference would be there? Um, Trino, I don't think so, but they do have Presto on their technology stack. I think they tested it before they picked StarRocks. The difference like 7 to 8 times performance difference without like pre-computation. Are there other StarRocks use cases you recommend we check out for customer-facing stuff? Yes, demand base has a pretty cool case study, and also Pinterest, a very similar use case than Xiaohongshu there. Yes, they do use symmetrized views. Sorry, this is another question. Yes, they do use symmetrized views. Let me check the chat. Yes, you're correct. Yeah, it's true. I mean, Iceberg still uses merge on read. So yeah, 10 to 20 minutes would make sense. But I really look forward to the Iceberg V3, the Delvec. That's I think is gonna make a huge difference in terms of real-time capabilities. I think that's it. Can I get the recording? Yes, this will be available on YouTube in 1 or 2 days. Okay, I think that's all of the questions. That's a lot of questions. Thank you guys for joining. If you have any other question, please do reach out to me on Slack, in the StarRocks Slack channel. And also, if you're not in the Slack channel, please, please, please join. And if you're interested in Cellular Cloud, go to this link and you can get your credit card free 30-day free trial. Okay, so I think this is it. Thank you. Thank you so much for joining, and see you guys again next time. Thank you.